we have the first problem here in the topic of derivative of logarithmic of functions. So let's say if we want to take a derivative of the function y is equal to log base 3 of the tangent x. The derivative with respect to x of the logarithmic with the base of a of the u is equal to u prime over u times ln a. We just have to find the value of our u prime and our a, as well as our u. This is our u. In our numerator, we need to find the derivative of tangent x. The derivative of the tangent x over our u, which is the tangent x, times the natural log of our base. So this is the derivative of our first function. Napakadali lang i-differentiate ng isang logarithmic function with the help of this function. So all you have to do is to find the value of the u prime, the u, and our base. So i-substitute mo lang and then yun na yung derivative ng logarithmic function. Okay, we have our second problem here, which is a trigonometric function. As we can see, we have a two function here, and we must use the product rule. So our product rule says dy prime is equal to u times dv over dx plus v times du over dx. So let's take the derivative of our equation. Y prime is equal to our first function, which is the tangent 3x, or the u tangent 3x, times the derivative of our second function, and we can write this function as sine of u. Why? Because this u stands as the function inside our sine function. So that's why we put u in that. So plus our v, which is the second function, or sine 3x, times the derivative of our u, or the first function, or we can write that as tangent u. So simplify it. This is equal to tangent 3x times the derivative of our sine u, which is the derivative of sine is cosine. So this will become cosine 3x. So in this time, we will gonna use a chain rule because we have a function inside the sine function. So times the derivative of our function u plus sine 3x. So the derivative of tangent is equal to secant squared times the derivative of the function inside in our tangent. Okay, so simplify it. The derivative of 3x is simply 3 because the derivative of x is 1. So 3 times 1 is 3. So simplify it further. We can move the 3 in the front of our function. So we can leave it like that, or we can simplify it further. So as we can see, we have our tangent here. We can simplify it further because the tangent is equivalent to sine over cosine according to the lesson what we've learned. So if we will simplify this will look like 3 sine over cosine times cosine 3x plus secant squared 3x times sine 3x. So as we can see, we have the same value here. So we can cancel this out, because if we divide that, that is equal to 1. So what we have left, so this is the final answer of our trigonometric function. Okay, we have our third function here, which is an exponential function. As you can see, we have a fraction function here, so we must use a quotient rule. So our quotient rule is the y prime is equal to or v times du over dx minus u times dv over dx and v squared. Notice that our u is our numerator, which is e to the x plus e to the negative x, and our v is our denominator, e to the x minus e to the negative x. So let's take the derivative of our function, our v, times the derivative of our numerator minus our u times the derivative of our denominator over our denominator with squared. Okay, so let's take the derivative of the two functions. So taking the derivative of the exponential function, we just take the derivative of the exponent and multiply it by our base. So the derivative of x is 1, e times 1 is just simply e to the x, plus the derivative of negative x is negative 1, so e times positive e to the negative x times negative 1 will become negative e to the negative x minus e to the x plus e to the negative x times the derivative of our denominator. Derivative of e to the x is simply e to the x. The derivative of negative x is negative 1. So negative e to the negative x times negative 1 will become positive e to the negative x. Okay, as you can see, we have the same function here and the same function here. So we can write that as e to the x plus e to the negative x squared minus e to the x plus e to the negative x squared. So we can simplify that. Okay, we have our derivative of our function, but as you can see, we can simplify it further using FOIL method, or we can factor that out. So notice that this function is in the form of a squared minus b squared, and a squared minus b squared is just equal to a minus b times a plus b. So this is our a squared and this is our b squared. So we can simplify our answer with this method. So let's try to simplify it further. A minus b, or e to the x minus, okay, so I put negative e here because we have negative e in front of our function, times a plus b. Simplify it. As we can see, we have a positive e to the x here and a negative e to the x here. So if we add this one, this will become 0, so we can cancel this out. And the same in our second function, we have negative e to the negative x here and positive e to the negative x here, so we can cancel this out. So what we have left is e to the negative x minus e to the negative x is negative 2e to the negative x times e to the x plus e to the x is positive 2e to the x over our denominator. So simplify it further. Negative 2 times 2 is equal to negative 4. in multiplying the same base, we will just add the exponents. So as we can see, in our exponent, if x plus x is just equal to 0, e raised to 0 is equal to 1. Negative 4 times 1 is equal to negative 4 over e to the x minus e to the negative x squared. So this is our final and simplified answer. Okay, we have our last problem here, which is a word problem, including our topic maxima and minima. So, a rectangular frame is to be made of a piece of wire 120 centimeter long. If the length is x centimeter, express the width in terms of x and find its area in terms of x, as well as find x for the maximum area and find the maximum area. So if I want to draw a sort of diagram here, as what the statement said, it is a rectangular frame, so this will be look like a rectangle. So let our length as the x centimeter and our width as the y centimeter. Okay, so we know that this rectangular frame is made of 120 centimeter. In other words, the parameter of this shape is going to be 120. So what's the parameter of this little rectangle? It's going to be 2x plus 2y, and it will be give a parameter of 120 centimeter. So let's solve for our a, which is if the length is x centimeter, express the width in the terms of x. 2x plus 2y is equal to 120 centimeter. So we can divide that by 2. So divide 2, cancel out. So 120 divided 2 is equal to 60. So x plus y is equal to 60. Okay, so we want to find a width. We want to find a width in terms of x. So let's make the y as our subject and move our x to the other side. So this is how we represent the width in terms of x. So this will be our a. So leave it here. Okay, so we already expressed the width in terms of x. So that is y is equal to 60 minus x. So let's proceed to our second task, which is find its area in terms of x. We will just multiply the length times width to find the area. So area is equal to xy, or the length times width. Notice that our y is equal to 60 minus x. So let's substitute our y, simplify. So let's leave it here. Okay, let's proceed to our letter C. So in letter C, we need to find the value of x that gives me the maximum area. Okay, so to do that, we want to find some sort of stationary point. Make sure that it gives a maximum area. So to find a stationary point, we are going to differentiate this area in terms of x. So let's differentiate our area. The derivative of the area with respect to x is equal to 60 times the derivative of x is 1. So 60 times 1 is simply 60. Minus the derivative of negative x squared, which is 2 times negative x will be 2x, negative 2x. So this is the derivative of our area. To find the stationary point is when my derivative is equal to 0. So let's move this 60 to the other side. So, para mawala yung negative 2, let's divide it by negative 2. So, our x is equal to positive 30. So, that's the stationary point for this area. But we still don't know if the stationary point is going to give me a maximum or minimum area. Now, if you want to confirm if it's going to give a maximum area, we're going to find its second derivative. So, from this derivative, we need to find the second derivative. The second derivative is the derivative of 60 is 0. The derivative of negative 2x is just negative 2. Our second derivative is negative 2. So obviously, negative 2 is less than 0. So what's that saying is, my second derivative is negative, meaning x is equal to 30. That stationary point will give me the maximum value. So x is equal to 30. That's a value where this area is going to be maximum. Okay, so finally, in our final task, which is to find the maximum area of the rectangle. So we will just use this equation. So to find the maximum area, since we confirmed that the value of x is equal to 30, which gives us the maximum area. So we will just substitute the value in our equation. Okay, so let's simplify. So 1800 minus 900 is equal to 900. So notice that this is area, so we must put 900 square meter. So this is the maximum value of our area. Okay, so that's all. Thank you.